because this is typically going to be something, if you're doing a fixed block size workload, that you'll need to understand. So the variable block size in ZFS is, it will try to figure out which blocks, or what will be the optimum block size for your workload, or for your writes, and it will try to coalesce writes to do it. So instead of doing, 16 8K writes, it will do one 128K write record size. So that's sort of the idea at the file system level of how we're going to do that. And part of that came about because of the realization that, certainly from a UFS perspective, where we have 8K blocks and 512 byte fragments, that whatever block size we pick, if we picked one, it was going to be wrong. So the idea is, well, let's just not do that. Let's make some sort of dynamically adjustable block size, and therefore we'll be able to more transparently behind the scenes do the right thing for you. In retrospect, the highest block size is 128K. And that actually turns out to be like the maximum record size for IDE disks or something like that. But in retrospect, maybe 128K is not the best upper limit. Those who do a lot of sequential writes would have preferred a bigger, higher block size than that. But 120K is the limit, something to think about. But it will scale down to whatever block size is needed. Okay. Now that if you have fixed block size workloads, Oracle is another example of that. Oracle likes 8K block sizes, then you will tend to be happier adjusting your max record size to match the fixed block size workload. Okay. So for generic home directory stuff, typically we don't change it. For fixed block or fixed record size workloads, you may be happier changing that. On the best practices guide, we do talk about that in some detail. You'll see a lot of banter in the forums about block size as well. All the performance guys will get all happy about block sizes. Okay. So that's one of the things going on there. Now a few more words about compression. I've kind of talked about in passing that we compress metadata, compresses very well. But we can also enable you to compress your data through a parameter called compression. No surprise there. The compression parameter, the way compression works is we coalesce these writes, we try to compress them. If they don't compress better than 12.5%, then we won't compress it, and we'll just send it out. If it does compress better than 12.5%, then we'll write it on disk as compressed. Okay. What that means is, in a dynamic sense, each set of records we're writing, or each set of blocks we're writing, may or may not be compressed, depending on how compressible they are. Okay. So it turns out this works fairly well for those mixed workloads. Like in your home directory, you may have a bunch of text files, but you may also have star office files. Star office files are compressed with zip, and therefore they don't compress additionally very well. Or JPEG files don't tend to compress very well with most of the common compressors. So those won't be compressed, but then a text file in the same file system may be compressed very well. And so you'll get this, again, this sort of dynamic adjustment of how much physical space I'm using versus how much space of data is available to me, which, again, back to those of you who worry about how much space I have free, well, we can't really say. It depends on your data. A couple of extremes. Zeros compress very well. So if you want a quick trick, what you do is you say, let's turn on compression. Now let's copy from dev 0 to this file and see how fast that goes. It goes really fast because it compresses away to nothing. So compression is all there. In Slurs 10 Update 6, you now have the availability or ability to do Gzip compression. So there's 9 Gzip compressors, and the default compression is a Limpel-Zev, a modified Limpel-Zev kind of algorithm. So Gzip 1 through 9 is available. It's the same algorithms as the regular Gzip. So you can kind of understand. In some cases, people know in advance that my data compresses really well with Gzip 7, better than Zfs, so maybe I'll make that choice. Okay, so that's how compression works. Again, this is done transparently. After it's compressed, we record the checksum, so we know how that works. It's also pluggable. So Gzip actually arrived there through one of the community members who said, "Hey, I'd like to integrate Gzip. You know, knock yourself out. Here's how you put it in." So that's how it came about. Now, similarly, we can also encrypt. Encryption today is a work in progress, and there's been some recent activity in this regard. Darren Moffat is the guy who is primarily driving Gzip or Zfs compression, or excuse me, encryption. And this is certain markets in particular, the credit card industry or the traditional intelligence communities really get worked up about encryption. So that's making progress today, and will show up hopefully before the not too distant future.
Excuse me?
Yes.
This compression and interesting. This happens while writing to the disk, or does it happen in the background afterwards? The compression and the encryption.
Okay, so we're pipelined, and it will happen as we go to commit the transaction group for compression.
Afterwards.
So that actually has implications now that the Gzip compressors are available in Solaris 10 Update 6. A lot of people don't do Open Solaris, they do Solaris 10 Update 6 or Solaris 10. And now we're starting to get people say, "Hey, this is slow." Well, part of the trade-off there is if I have a slow compression algorithm versus a more efficient compression algorithm that maybe doesn't compress as well, we have more things to trade off. So there are cases where this occurs. We also, the compression is done through task queues, so it's done in parallel. So also I can notice this on a multiprocessor machine as well. So there are cases where that compression will be noticeable in your workload. And if we get in very much into performance, we can talk more about that. Yes?
Will that be done on a pool basis or file system?
Compression is done on the file system.
On the encryption?
Encryption will be as well.
And what is the point about Gzip compression if you can't set it on your root pool? So for those of you who are looking at moving,
Can't set it on what?
you can't set it on the root pool if you're going to use
Gzip is not in Grub yet. So if you Gzip your root pool, then Grub can't.
Things may happen.
Yeah, I
Figure it out.
think
No
you get a
booting.
message like this
Yeah.
was not supportable or something.
Yeah, you gotta have some sort of bootloader that understands the encryption
Yeah,
or compression.
So there's a lot of issues when we get into this topic of booting specifically. I'd like to defer till then, that deal with all these other things like BIOSes and bootloaders that have to be addressed. So if we can defer those to our boot discussion, I'd like to. Okay. Yes.
When you turn on, that's done with new files, not the old.
That's correct. So a lot of these features, copies, compression, basically the ZFS level features apply to newly written files done after the feature is enabled. Okay. Which leads to a very frequently asked question, and that is, I have a file, and now I enabled compression. How do I make the old file compressed? And the answer is you copy it. Because when you copy it, you create new writes. The new writes will be compressed. So that's sort of the pedantic, easy way to do that. And there's other things, but it won't go back through. Since we did a copy and write, we have these snapshots. We're not going to go back through and overwrite that data that we didn't want to overwrite as a general policy. I'll leave it as that. Okay, let me accelerate just a little bit. I'd like to say a couple things about Zfs Administration. That there's basically two commands. One is zpool and one is Zfs. Zpool works for your storage pool, and Zfs works for the file systems in the storage pool. And just to make it easy for you, when you create a storage pool, you'll have by default a file system of the same name. Okay, so one of the things that you'll stumble across or come across is that in some cases we'll have a confusion about whether we're talking about a zpool kind of operation or a Zfs operation. The best thing I could say about that is through experience and after experimenting, and once you get better, more experience with it, you'll automatically figure out which one you're talking about. I'll also make a short plug. There is a browser user interface for this. I don't know how well it's working today. Arguably, let me put it this way: there's few people who use it to an extent that they logged a lot of bugs. So on the one hand, that's good because of the command line, Zfs and zpool, the two commands you actually need to know, and then there's sub options to those. But a lot of the stuff that you would ever do in a traditional system administration context, those two commands will suffice. So you're probably going to want to understand those. For the command line impaired, there is a browser user interface, and then with our new announcement today, we actually hide that through another browser user interface as well as a different command line interface as well for the Storage 7000 protocol. Okay, so that was part of the thing, is that how can we make system administration of this thing be more simple and concise for you guys? Hopefully, I think we've done a fairly good job. Over time, as you add more features and flags, the man page gets longer, right? Well, sorry about that. We'll go through a couple of examples here for those of you who may have never actually done a command line for this. In many of these examples, they use a pool called tank. You'll see that a lot. I see field data from people. If you run Explorer data and send it back to Sun, then one of my jobs in figuring out how things are doing in the field is I have programs that give me statistics based on this thing. And tank is a very popular name for a pool. I call mine stuff, but So you'll see tank, you'll see my pool a lot. But tank is the name here, and basically to take two disks and create a mirrored pool, that's all you have to do, right? Zpool create. My name is tank. It's going to be a mirror with these two devices. Okay, that's pretty simple. Then if we want to make a file system under that under tank, then we just do a Zfs create tank /home, and gives it a different thing. Now, when we did this, we actually then set a policy. So we said Zfs set. So there's Zfs set and Zfs get. Again, common one you'll look at. We set the mount point parameter to be a different directory than the default. So the default for this Zfs create will be /tank/home, and now we're going to set that mount point to export home. Now the reason I want to spend a few minutes here talking about that is I consider that a policy. So my policy for this file system is to set the mount point. Okay, I may have a policy enable compression. I may have a policy make the copies equal to. There's I don't know, what are we up to, about 24 or so policies that you can set on a per file system basis. Now the reason I want to say policies is because if you don't have a good reason to make a policy, you're probably better off not making a file system. Okay, so, question?
Now, when you do Zfs create tank/home, that's got a mount right away, isn't it?
Yes.
So you then have to set a mount right again.
Well, when you do this, it will unmount and do the right thing for you.
So when you run the second command, it will unmount it.
Mm-hmm. Yes, and if it's busy, it's going to say, I'm busy.
You essentially could do it all in one line created. With
Yep.
-O.
Yeah, there's a -O option here, right, Cindy, that
Yeah.
you can put it all in one line.
Do these mirror members have to be exactly identical size?
Nope. Okay, so this is an excellent question. For mirrors, do they have to be the same size? And the answer is no. Which actually, believe it or not, is one of the best things since sliced bread. The available space will be the lesser of the two sizes. Okay.
They do have to be devices, not slices.
They can be slices. In this case, we're doing devices, but it's more. I think it's more common to do slices, especially when we're talking about boot devices. But sidebar, good sidebar conversation. What happens if I give it a device and not a slice? The answer is, when I give it a device, it's going to assume I have the entire disk available at my disposal.
Maybe that's a good assumption, maybe not.
Maybe that's a good assumption, maybe it isn't. But what it will do is it will write an EFI label on that device and take over the whole device. Now then, there are some machines, particularly x86 machines, with BIOSes that hate EFI labels. And they hate them such that you will not be able to boot that machine again until you update the BIOS. Okay? So, this is one of those things where, okay, we're trying to proactively make things easier, but we may have set a landmine for you here. Okay? So, I have a question here.
If you try to add an STI label slice, will it be able to accept it?
Yes.
Okay, but if you mirror one to another, is that going to break it all?
No?
Okay.
So if you give it a device, it's going to try to take the whole device.
Yes.
And if you give it a slice, it's going to take the whole slice.
Yes.
Is there a way to limit it?
The way you want to limit it is to partition or set the slice.
No, but like say use the slice, but don't use the whole slice.
No, not really. Because it's going to assume that it has rights to use the whole thing, and it will actually write labels at the end of the device. So it writes labels at the beginning of the device. There's actually 4 labels that are written for redundancy, 2 at the beginning, 2 at the end.
If you want to get really extreme, you can actually put it onto a file, right?
Yes. So it looks for a block device. So whatever looks like a block device, it will use. Okay. So there's no assumptions that ZFS makes about what's underneath here. I would say, other than this assumption, if you give it a whole disk, it's going to take the whole disk. And again, it's going to do it with an EFI label. That's a gotcha. So you want to make sure that you're aware of that. And the easiest way to stay out of trouble is to use slices, to be honest. This is one of those things I would say this is a frequent question. And occasionally people do get bit by it.
That's generally only a problem on the x86. Probably not going to be a problem on Spark, I would imagine.
Generally more of a problem on x86, I think.
Well, non-Sun x86.
No, even Sun x86. Yeah, we run into this fairly regular.
So moral of the story is slices when possible.
I think so. I mean, okay, so
or put it in our RFP.
Let me explain kind of why this really makes a difference. And it's not just so much the EFI label thing versus the Sun VTOC label, which is one issue. The other is that getting back to devices live, a lot of devices in the PC space have volatile write caches. A lot of the disk drives have volatile write caches on them. Like a SATA drive may have a 32 meg write cache, and it's volatile. And so, if you're using UFS on that, then you want to disable it because UFS has no idea that there's a volatile write cache there. And when power goes out, it may have to do an FSCK. If it's a terabyte disk, you may be twiddling your thumbs for some time. ZFS, though, in its transactional model, knows when data needs to be on the platter and will send a flush data from your cache command to the device. Okay. So the thought is if we do it this way, if you give ZFS a whole device, then it knows it's the whole device, so it will enable the write cache. Whereas for UFS, we'd rather disable the write cache. And so if you have a mixed system which has some file systems UFS and some file systems ZFS, then you don't want to disable or enable the write cache, right? So the assumption here is not only am I going to put an EFI label, I'm going to take the whole disk, but it's also I'm going to turn on the volatile write cache. Okay, and that's the assumption that's made when you give it the whole disk. So I think Neil Perrin actually did a study. Does the non-volatile write cache make any difference in performance or not? And the answer is yes, but not in all cases. Neil has a blog, something about that. So that's kind of the other gotcha about using whole disk devices. If you use a slice, then it won't try to turn that off. Sometimes you can't turn it off even if you want to. Depends on the hardware.
Is that going to be in any of the best practices documents that you know of?
Yeah, I think we have it. I think we have it several times.
Okay.
Because
I haven't done enough reading on it yet.
Yeah, it's a frequent question. And like I said, usually we'll get a complaint, something to the effect. This happens about once a month or so. Somebody will come on the forum and they'll say, "I installed ZFS, and then a month later my machine won't boot." And you root cause it, and you find out that they wrote an EFI label, the BIOS can't handle it, but you don't know it until you try to reboot.
Yeah.
You wait a month to try to reboot, and you're in trouble and have to relabel the disk. So again, that's a pretty good gotcha to know about. Okay, so that's an example there. Here's more examples of setting policies or properties, as they're called, parameters. There's about 24 of these. These are actually some fairly common ones. Quotas, compression, share NFS. When you set the share NFS property on a file system, then by default when you boot, it'll do an NFS share. There's also share Zfs, so if you're on Open Solaris and want to share to PCs with an SMB protocol or Zfs protocol, there's a share Zfs. There's also a share iSCSI parameter as well that's really more intended for volumes than file systems. But yes, questions?
Does it accept all the, if you have several shores, do you want to all the syntax of the normal share command?
Yeah, so you can, correct me if I'm wrong, Cindy knows this. If I want to do like read write, root equals, one,
Right, comma.
you do comma.
Right. So,
Yeah. So the trick is that now I can do this in one line, and it all happens behind the scenes. If NFS service is not started, it'll start NFS service. I don't have to go edit VFS tab or DFS tab or whatnot.
Your Zfs, is that using the bundle Samba or is that separate?
It's an internal.
It's the
Is it not available
internal
commercial?
Zfs.
Open Solaris only.
That didn't make update 6, did it? Zfs?
No, they can't backport that.
Oh, can't backward it.
I've read that it's not going to be in any plan update. Is that right?
But it's not using Samba, it is,
It is a native Zfs implementation tied into the kernel, so.
and it's in the Nevada, the Solaris Express Community Edition.
Because regular Samba is the regular Solaris 10.
Yes.
Yeah.
And regular Samba will work, but you won't,
Yeah.
you have to set it up
Yeah.
the regular way. So we have that going on. So share NFS, share CFS, CIFS, and share iSCSI are probably the three most interesting, at least in the open Solaris community. And again, from a system administrator point of view, now rather than editing all these files like I used to have to do, I just type it on the command line and let it rip.
But sometimes it's not, you can edit the file. Does it go into the CFS?
No, it doesn't edit the Zfs tab for you. It will store that parameter as part of the file system. And so, so if you want to change it, you just set it again.
Is that not persistent through a reboot then, or?
It is persistent through boots.
Is it stored in some way that you can read it, or?
Yeah, so there's a get property. So I can do a Zfs get share NFS,
Okay.
and it'll tell me what it's set to. And then DFS or DF shares will show it as exported. And
We will show, okay, so
Yeah.
so you can easily see what is exported without checking each one.
yeah, absolutely. So again, we're trying, from a system administration point of view, we're trying to do a lot of the grunt work for you in these things. Okay. What else do we? Any other questions on sharing command line? Yes.
I just wanted to note that when you do the IP addresses that are allowed to mount the NFS, you have to use the @IP address /prefix format, or it doesn't take it unless that's been fixed recently.
Good question. I don't know. Cindy, make a note.
Does that work with net groups?
It should work with
Can
NetGroup.
you share out based on net group membership?
Because that's just a parameter.
Network records.
Yes, we do that.
Somebody said they do net groups?
Yeah. And that group stuff works. That just needs to resolve your name service.
Yeah.
Large, never done net group call files in NFS.
Yeah. Why is there not a files version of net groups?
Yeah, that's good.
Oh, I hate that.
Damn irritating.
Thank you.
Can't explain. Can't explain. There's some things in life I can't explain. Women and trash is one of them.
The women in net groups.
Women and net groups. Especially my wife. Can't explain. Any other questions? Okay. Yes.
Oh, we're also having trouble sharing IPv6 networks. The syntax is like
IPv6. There's another thing I don't understand. Cindy, could you make a note and let's see if we can, because IPv6 has been basically zero activity until Chuck, like the last 3 months. Then all of a sudden.
Well, a lot of government RFPs are requiring IPv6, but it's a checkoff. But all the vendors that are doing stuff, it still need a bridge because nobody does IPv6 end to end.
All right. So IPv6, I don't think it's well tested or widely used in general, and therefore we're going to need some people to blaze the trail there a little bit. Yes, question?
We are starting to dip our toes into IPv6 now, so I'll add my support for that.
Yeah. My only suggestion is to file those bugs regularly and often. So, and again, just because in theory the stuff should work, but there's just I don't think there's a lot of experience, and certainly not a lot of end-to-end work being done. And like Chuck says, we're starting to see a lot of it in RFPs from the government in particular, IPv6. But they did that with Ada, so you know what I mean?
Oh, Ada.
Cobalt.
Huh?
Cobalt.
Yeah. Yeah. I lived through the Ada thing. Yes. What time is it?
It's that time. Coffee's out there.
Let's take a break.
Oh,
Can we meet back here? We left off, I think I was on the snapshot slide here, or at least that's what I'll claim. Because we did talk a little bit about snapshots, and I know some people have been using them extensively, and some people probably never ever used them. But they are pretty darn handy for a lot of things, particularly backup and restore, for a variety of reasons. And so let's spend a few minutes talking about snapshots. The way to make snapshots real easy, we just say ZFS snapshot, give it the file system name, @ and then some text of some sort. And so basically what you can do then is, in this case, Mark's home directory, we're snapshotting on Tuesday. Okay. So what that does then is, like I said before, the copy on write blocks are not returned to the free pool at that point, and so they continue to take space on the disk, but it's read-only access to that snapshot. So a couple of things that occur from the snapshot's perspective in ZFS that we can leverage from that. One is, suppose Marx is doing a development of something, and so he's experimenting wildly, and the experiment doesn't work out the way he likes, and so he wants to roll back to his previous snapshot, and that's simply a ZFS rollback. Give it the snapshot you want to roll back to. Okay, so now I can take a go forward or not. Now there's another, I'm not sure if it's on my slides, we can also clone a snapshot. So we can take a snapshot which is a read-only environment, and I can clone it, which gives me then a read-write copy of that. Now it's a clone of the original file system, and I can take that clone through a whole other path of development, right? So I think clones are very useful for things, especially software developers, in particular, people who like to experiment a lot. So, question?
Well, over time, how do you delineate, like Tuesday at 8 o'clock, Tuesday at 4 o'clock, Tuesday at 6 to 7?
How do you delineate? What do you pick here? I guess the good news is it's flexible. The bad news is it's flexible. However, in Nevada Build 100, which means it'll show up in Open Solaris 2008.11, and has been available actually for some time on Tim Foster's blog. There's a snapshot, automatic snapshot facility, and it connects into the System Management Framework, SMF, in Solaris, and with that you can have it automatically create snapshots for you. And when it does that, it uses a date code, so it's like 2008-11-10-1200, right? So you'll have a human readable timestamp on the automatic snapshots. And maybe later this afternoon I can go through some examples of what that would look like. But it's an SMF service. And not only does it take the automatic snapshots, but you can set the policy in the service to say, okay, when my disk is 80% full, I'll start deleting old snapshots. So we're integrating that then into Nevada, being the next major Open Solaris update, and at some point in time, it may integrate back. As I said, it's scripts, so it's relatively easy if you understand. Some of it's Python, so if you can do Python, coin shell, you should be able to figure it out. Okay, I had a whole bunch of hands here. So let me start here.
You touched on some of it with sizing. We're stuck on, we use production environments, like we would always use facilities-wise. Something we come across for snapshots is we take for antiquated systematic explain there, and we also use it for sort of grade as well. We take multiple snapshots and you end up, you can look at the overall size of what we've got for snapshots, but when we run out of space and we need to delete a snapshot, we can't establish which one's big, which one's small. We can educate guess by going with the oldest one, because that's why it's moved further. But is there something in OpenSpice that lets you establish the size of an individual snapshot?
That's one of those. Okay, so Cindy, if you can refresh my memory, when did the reference count show up?
You mean the quota and
No, for when you do a ZFS list snapshot.
oh, right, and it tells you now used by data set, used by snapshot.
Yeah.
That was like 100 or 101.
Is it that late? Yeah. Okay. So.
Oh no.
No.
I have it on my whiteboard.
It must have been.
It could be it was in the 90s.
80s or 90s.
Yeah.
Okay. So don't know if it.
We'll roll back into.
Yeah.
Don't know if it made update 6 or not. I think it's.
No.
Did not make update 6. Okay. So yeah, there is. With Solaris in Nevada, there is a way to more accurately tell what that is. It is a matter of doing some math behind the scenes, right? So, question?
So you're taking a snapshot of the home directory requirements. Where does it put in the snapshot? In the tanks?
Yes. So it stays where it was.
Richard, it's in the November release. I have it up here.
Okay.
It was.
Definitely a November release. So I want to say it was late 80s.
Yeah, I think.
We talk in builds, by the way.
Late 80s or early 90s.
Late 80s and builds. And builds occur every 2 weeks. I've actually got a slide I want to go over with immediately after I get through this presentation to kind of give you guys a level set of exactly what we're talking about when we talk about builds and whatnot. Question?
Do I have to edit find commands to not descend into ZFS directories?
Excellent question. Do I have to edit find commands to not descend? The answer is it's configurable. By default, it won't. So by default, it will not. Things like find won't enter into. Yeah. So it's not shown on here, or yeah, it is here. So underneath this file system, there'll be a .zfs directory. If you go there and you do an ls, you won't see it, but you can CD to it, and it's there. And that's the reason why we won't find it, because it basically does so it's there, and then there'll be a snapshot, and then the snapshot name. So in this case, it's Wednesday, and then everything is underneath that. Okay. So, question?
Can you do that on other OS file systems? Like, for example, we had an issue where somebody who had elevated access did a chown on the entire Etsy directory.
Oh.
And it was catastrophic. However, in this case, if we had still had access to the box, could we go in and do a rollback on root, for example? I mean,
yes.
On a running system, would that work?
It won't work on a running system in the sense that you would want to do it in single user reboot for root specifically.
Okay. Just
to make sure that everything's properly caught up. And there are, in fact, other ways to recover from that specific scenario. But yes, that is a snapshot capability that we can do. So what you'll have then too is that there's all these snapshots underneath there. Now, the other thing, and maybe I'll be able to demonstrate it later this afternoon, is how many of you have Macs? I see a bunch of Macs. And then in Macs, if I get the name wrong, is it Time Machine? Time Capsule? Time Machine?
Time Machine.
I knew it was Time something. You have a Time Machine, so you can configure that, and it basically does the same sort of thing. So it takes snapshots at midnight, and then you can roll back. In Nevada 100, as a companion to this automatic snapshot feature, and there's a GUI way to enable that. Nautilus has also been updated to manage that as well. So there's a little, life preserver icon there, and you can connect on it, and then it'll show a time slider And you can do the same sort of thing. I can go back in time in a novice view and see the prior snapshot version of that. Now, the thing I thought was really cool of it though was I ran it on my home machine, and it came up and it said my oldest snapshot was like 829 days. So, I've been running ZFS at home now for, I guess, about 3 years. And that's where my home directory is, and my wife's as well. So you can tell I live on the edge. But I thought it was pretty cool. And in fact, so I posted this to the group. I said, hey, this is kind of cool. My home directory goes back 829 days. And I forget who it was. Somebody said, oh, darn, that's a bug. But he said, but the bug is not that it's 829 days. The bug is that that's not very readable. I mean, you'd rather it say, it's 2 years and 3 months, or 2 years and 47 days, or something like that. So the bug was filed to make that, instead of 829 days, it'll say, 2 years and whatever. So, I guess those guys had never tested with snapshots that old, which makes some sort of sense, I guess. Question?
Are you coming up with a way to be able to delete files? I started running out of space on my system the other day and tried to go through and clean up, and the only way I could get my free space was I had to delete the entire snapshot set.
Right. Okay. So another frequently asked question is, how do I delete a file out of a snapshot? Because snapshots are read-only. And the answer is today, you don't. I have no idea where that stands. Cindy, let's make a note and get back to him on that, because in theory it shouldn't be impossible, but don't know how it stands on the priority, because I think there already is an RFE assigned to this, but I don't know where it stands on the list. So today assume you can't, and then we'll see what the future holds. We'll get back to you on that.
There's also a question here about the performance of snapshots.
What was the performance there? Well, along on the snapshots.
In general, the performance impact of having a snapshot and just operating normally, you won't notice it. And the performance impact of taking a snapshot is very unobtrusive as well. And you'll barely notice that as well. What we don't know, and part of the task I'm looking at most recently is, okay, I have all these snapshots, but now I want to go off and start deleting them, and I want to do this on a production system that's under heavy load. Well, when I delete that snapshot, I've got to basically travel the metadata and free up all these blocks. And my prediction is that's not a zero load. So I don't know what it is. And so I would classify that as an active bit of research. Is, okay, we know taking snapshots is easy. We don't know if managing snapshots is as easy. In particular, what happens when we delete snapshots. So that's a question that we're trying to find out. I don't know the answer to that just yet.
I know the snapshot manager will rotate the snapshots, right, based on how much file system space is left. I can't remember if the removal of the snapshots was like at 2 a.m.
Yeah, I don't remember when that would be scheduled. Probably not 2, because 2 is a bad time to schedule anything. But the only thing you want to schedule at 2 a.m. is setting your clock back to 1 or forward to 3, or however daylight saving time works. Okay, so and then later on, I'd like to have another discussion of creative uses of snapshots and how we can how that works and how to make it better. I mentioned this before. Clones, I take a snapshot and make it writable. We actually do not write the snapped files. Remember, the snapshot itself is still maintained as read-only. And so what I can actually do is I can make a whole bunch of clones from one snapshot. So Where the people are getting real excited about this is also managing zones. So the idea is that I build my prototype zone, and then I snapshot it, and then I start cloning off copies of the zone. At this point, I will put in a caveat, is I haven't used zones in years, so I don't know how well this is or is not working. If you're interested in zones and snapshots, maybe you can enlighten us.
Looks good.
Does it? Yeah. So we'll maybe put zones in as part of the conversation this afternoon on snapshots. Let's see. Next slide. Send and receive. Once I have this read-only copy snapshot, then the developers said, hey, I've got this data and it's read-only, and so how about if I take all those objects and put them in a stream and send it to someplace else, and I can replay that stream of objects and relay down a copy of the snapshot. Okay, this is very cool, and it does in fact work, just as I described it. At this point, I have to put a big caveat. Send and receive is not a backup solution. Okay, because for many reasons, but not the least of which is that we take an entire snapshot. So our unit of operation on a send and receive is a snapshot, or a difference between two snapshots. Okay, it's not files. And what happens is many people who do want to back up their files may want to restore, say, one of them. So I back up my home directory, but I want to restore my .profile. So I go to the backup tapes, I do a restore my .profile, and I get it back. When you send a snapshot, or you deal with the snapshot level with send and receive, you're dealing with the entire snapshot, or an incremental snapshot, not a file in a snapshot. Right? So I don't have the ability to restore one file out of a snapshot through send and receive.
But you could wrap a process around that.
So where we do see it as being useful, though, in a backup sort of mode or disaster recovery sort of mode, is where I have a duplicate machine or a duplicate set of storage someplace. And what I really do want to do is have a fairly recent snapshot of my production environment. And for that, snapshots are a pretty good way to manage that. So for large data sets that take many hours to dump off to alternate media like tape, even with VTLs and that sort of thing, we do see people implementing architectures. Well, I have a production system, I have a backup system, a nearline backup system. We do a send from the production system, the snapshots, receive them on the backup system. From there, we then spool off the tape. Or from there, we go to the disaster recovery site, or something like that. So we do see that sort of a closely coupled thing occurring for us being able to send and receive snapshots. The main takeaway I want today to get across is that don't think of it as a traditional enterprise backup thing. Right? It's not going to replace Networker. It's not going to replace NetBackup. It's not going to replace Amanda. It is sort of a new capability that we get for free out of snapshots. So, question?
How efficient is the send and receive from the settlers snapshot?
Excuse me, how fast is it?
How fast can you send the snapshot to another storage box?
How fast can you send a snapshot?
Like number with 84 disks.
It's an excellent question, and there's a couple of different components to the question, and one impedance matching problem. Trying to think if I want to get into this today or defer it till a little bit later. In general, when you do the send, we have a fair amount of metadata sorts of reads to occur, and these reads tend to be random. Okay, so we are injecting into the system a random read workload. Typically, in this case, we're also traversing a network, and so we have a network pipe bandwidth. So that's part of it. And then there's an impedance mismatch that occurs on the receiving end. So on the receiving end, right, I'm receiving from the network and I'm writing into a new file system. The actual writes occur mostly sequentially, so they're fairly quick. But there is this like a tape hitching activity that occurs between that read and the write. And so some of the new thinking along this line is that maybe some sort of a buffer in that receiving end is a good idea. So some of the guys are using memory buffers basically to buffer that incoming workload and make it a little bit more streamy going out the backside. And we've seen an order of magnitude difference in the performance based on implementing these techniques. So kind of what I would say as a takeaway from that is you will be 100% utilized at some point of your architecture. We just don't know exactly which point along that continuum you're going to be. So it's hard to, in general, say, here's a magic wand to fix the performance problem there. So, any other questions? Snapshots, clones, send, receive? Yes.
We have this situation in our department where we have a primary file server and the secondary one. And they're not like real mirrors. The secondary one is, if you like, 24 hours behind, which is acceptable for our company. And at the moment, we use rsync nightly to make them identical. And we're currently looking at send and receive functionality. And with rsync, you have to evaluate the whole tree of files.
Right.
And it takes about 2-3 hours before the data actually gets sent. So with Zfs send and receive, do you think will the data be sent instantly, or will it take time to evaluate the data on the primary server?
Compared to an rsync, using that technique, and by the way, rsync is good stuff. So a lot of people use it. It's well proven. But we are talking about a little bit of a different scenario here with snapshots, in that we don't have to traverse the file system looking for modification times. We know in that tree of blocks of metadata, we know exactly what it is we need to send. So that part can go faster. Now, having said that, there is a bug that it takes 30 seconds longer than it ought. And there's some other performance enhancements we think fit into that send part of the code. So I think it'll be out rsync in that case, but it won't necessarily be as good as today as it should be. Now, another thing cognitively that you need to understand about snapshots that's different from an rsync or a net backup kind of world, in that snapshots occur with blocks. They don't occur with files. Okay, now this is an important distinction. So if, let's say I have a file and I take a snapshot on Monday, and then Tuesday I append to the file and take a snap on Tuesday evening. The snapshot is only, the incremental snapshot is only going to contain the blocks I added to the file. It won't contain the whole file. Okay, so you'll see me pipe up on the ZFS Discuss forum, and I'll say, if people are thinking that snapshots contain files, they don't. They contain change blocks. Very big difference. Which means if I want to restore a file, then I have to have all predecessing snapshots of the file, including the current one, to have all the blocks of the file, to know that all the blocks of the file are there. Okay, so again, this is a difference between like an rsync. rsync will send the whole file over. A snapshot will only send the changed blocks over. So a cognitive difference between the two. And in truth, you may actually want architectures where you utilize both techniques. I make copies of everything, so multiple copies of everything, many different ways. So, question here.
How stable is the format of these send files? Can I do it same with this backup and restore it? They run later versions instead.
Okay, so how stable is the send protocol? Is the question, and it is an excellent question. To date, we've only had one backwards compatibility change, and that occurred at build 36 or 34, back in build 30s. And probably I would wager none of you have ever experienced a build in the 30s or before in Nevada. And we had to change that to fix a bug in the current system. So an assumption was made that impacted that protocol. Okay, if you read the man page on it, there'll be words that to the effect of "this is not a stable interface," you know, boo. We're trying to scare you, right? Stay away from this interface. And it is the case that there is a forwards compatibility story here. So we're trying hard not to change it, but it's not cast in stone because in fact the features are not 100% complete. And also we really only talk about forward compatibility. So if I have a ZFS update, or ZFS pool, or ZFS file system, Rev 3 going back to a ZFS file system, Rev 1, do send and receive won't work. It should bail out with an appropriate error message. We try to do that. Okay, so that's what we're trying to keep forward. And again, in the spirit of this is not a replacement for TAR and CPIO and all these other kinds of file system level backup protocols. Okay.
You touched on how Snapshot works, which is confusing, but how it just keeps a copy of the change block. So initially your Snapshot is on 0 start. Is there a performance hit if at a later date, let's say your Snapshot is something that has file system has an ongoing database on it, and the data file changes and it's 20 gig? Do you then have to go through the whole copy on write block scenario and copy a 20 gig file? So is it a random point down the line because your file system is suddenly get very busy?
Excellent question. And I'm going to lump that into the fear of fragmentation category, because it is possible that if I've got one file and I'm updating individual random blocks to take the worst case of that file, then what was probably a serially sequential workload becomes now a random workload. And so if you're using a magnetic disk, you may notice this. And in fact, if you're using a application such as Oracle, which tries to manage its disk with the same level of optimizations, then the theory is that that Oracle, your once sequential operation on the disk now becomes a random operation on disk. And so basically that's the theory. What effect does it have on the performance of the system is the argument of raging debate, in that it's very difficult to predict. It's very difficult to assign a latency, because really you're changing the latency of the reads. It's difficult to assign a latency figure to an impact in performance directly. So it's real hard to tell. What the hybrid storage pool model says is the following, and that is, with the hybrid storage pool, am I getting ahead of myself? I'm going to get ahead of myself. Let me not get ahead of myself. We'll come back and talk about hybrid storage pool. We'll talk about the fragmentation thing and later today. Yes.
I have a question about the snapshot. I created a pool, created a file system in there, and then they made a file 300 meg, and then it was a snapshot. They created another 300 meg file in the same directory under .cfs. Does that mean you need a one-to-one space?
Right, so you have another view to that file, but there's actually not a copy of the data.
I see it in the directory, .cfs snapshot.
Yeah, straight to you, it's not using that through the reg unless you change that file.
All right.
So initially, your snapshot is zero, there's no zero size. It's only one change.
So does it just keep track of the blocks that have changed? I mean, is that basically all it is? But when you're looking in the snapshot directory, you see the entire file, but the unchanged parts are still linking back to the original one?
That's correct. Yeah, so again, you have a view of the consistent file system in the snapshot, but then the actual blocks may be different than the current operating writable file system. And then carry that through to previous snapshots as well.
Isn't the refer column the one that shows what's actually used in that particular instance?
Yes.
Is it possible to separate your network for send and receive? Or is that this?
So the send just writes to standard out, and receive receives from standard in. Another thing about the send and receive is data will come through uncompressed. Whatever policies that you have on the send side can be different than the receive side. So an example where I might use that is on my production machine I may not enable compression, but on my backup machine I may want to enable compression. And so I can send an uncompressed. When I send a file from the production system to the backup system, on the backup system I can have a different policy. I can enable compression.
Okay.
As an example.
And the policy you can also assign some other interface cards.
I missed the question again? We can assign...
For send and receiving, you can also use different interfaces?
Yes. Yeah. And it just goes through a pipe. So one of the questions that we often get asked is, well, if I'm sending this as clear text, basically, now I want to encrypt it.